practical application time. It's practical application time. All right, here we go. Let's read it. Diver jumps from a 3-meter springboard. Okay, is that important? Yes, because if you think about it, here's the diver, there's the springboard, okay, da-da-da, there's the water underneath here, and the 3-meter high here. They're going to jump up, and they're going to go splash, right? Okay, right. So it says it jumps from a 3-meter springboard with an initial vertical velocity of 6.8 meters per second. Okay. Her height in meters above the water's t seconds. T seconds. So time is t. Okay. After leaving the diving board can be modeled by the function of this. Okay. So let's interpret what the heck that means because I have no idea. Read it again. Diver jumps from 3-meter springboard. Initial vertical velocity 6.8. Her height is in t seconds. After leaving the diving board, it can be modeled by this function. Okay. All right, here we go. Ready? What's this? The height. This is the height as a function of time. Okay, as a function of time. So look at there. There's the t squared. There's the t there. But where's the 6.8? Maybe that has something to do with this guy. I'm not sure. That's kind of interesting. Now, in a question like this, I would have to give you the formula. Okay, either that or I'd give you enough information to go out and find the formula in vertex form and then convert it to standard form. But I can't just leave you in the middle of nowhere thinking that that's the question or you determine what the function is. That's too hard. All right. Okay, so here we go. Graph the function. Well, first thing I'm going to do is I'm going to bring up my calculator. And I'm going to put everything in the calculator. Why not? There's minus 4.9 t squared. Well, we don't have a t, we have an x, but the same difference. X squared plus 6.8x plus 3. And I'm going to graph it. Okay, here we go. Graph. Yikes. Well, here's a couple things that are kind of interesting. Let's start talking about domain and range right off the bat. I got a question for you. Is this part of the graph in here important? Well, no. Apparently you start at 3 meters above the water, you do this little dive and you dive into the water right there. That's all that's important. All of this stuff is not important at all. You just want this little tiny little piece of the arc. That's where domain and range comes in. Aha! So we're actually going to start restricting the domain and we're going to start looking at a specific range. The range, of course, is going to be anytime you're above the water, right? And all to the point where the diver splashes into the water. And in terms of time, think about this because the x coordinate is time. That's time. You care about from 0 to the point that the person lands in the water. You don't care about any other point. So now we're restricting the domain from 0 to the point where the person splashes into the water. Well, what does this mean for our graph? Well, you know what? I'm going to change a few things around here in this graph. Number one, I don't need all of this stuff down here. I can actually shrink this. I certainly don't need negative because if this is time, you can't have negative time. That's impossible. Okay? Forget that. So get rid of that. I don't need all that extra out here. I just want to concentrate 100% on this portion right from here to here. Right from the time she jumps off the board to the time that she hits the water. So let's shorten this up. Let's bring this up to, let's say, -1. Let's shorten this up. Let's bring this up to, again, about -1 here so we can at least see the splashdown. Okay, we can shorten this up because look, this particular thing is going to take us maybe 2, maybe 3 seconds. That's all we're dealing with here. So let's shorten this up to about 3 seconds. Okay, so our x values are now from -1 to 3. Look at our y from -1 to how high is this going to be? 1, 2, 3, 4, 5, 6. Let's go to 7. That's all we have to do. So we're going to change the window setting on this. We're going from -1 to 3 in the x. Okay, so I'm going to clear this out of here. From -1 to 3 in the x window, from -1 to 3 in the x. Okay, In the y value, we're going to go from -1 again, just below the water, to a y value of about 7. And now let's take a look at this graph, and we'll probably get a much prettier graph. Oh, look at that. That's so much prettier. Okay? Notice a couple things, right? What's the y-intercept? The y-intercept is right there, and of course, that's going to be this value right here. It's at +3. Why? It's a 3-meter springboard. They're starting from 3 meters above the water. So this, in fact, is part of the arc. You're starting right here at the y-intercept. That's where the xy axis would be. See it? Wow, some really interesting stuff here on this one. Okay, so the y-intercept represents the starting point. What maximum height? Let's figure it out. Second calc. Let's find the maximum. There's maximum, number 4. Okay, left bound over here. Okay, there's enter. Right bound, which is over there. Enter, and guess, you betcha. And you're going to find out at 0.633. Okay, let's make this a little bit wider because I can't even see this very well. So it's at 0.69. 0.69 right up here, okay, is 0.69. So just over a half a second into the dive, she's at a maximum, and the maximum height is 5.36 meters above the water. Holy smokes. So that's the maximum height right there at 5.36 and at 0.69. So let's go back to this now. Y = 2. Maximum height, and when does the diver reach it? Maximum height was, again, right, do you remember? 0.69 at time and 5.36 in terms of the height. So 0.69 in terms of time, 0.69 seconds, and the height of 5.3, was it 39? Double check, 5.36. Aha, 5.36, okay? There we go, 0.36, there we go, meters high. Look at that. Look at the information you can get from the calculator on this, okay? How long does it take before the diver hits the water? Okay, well, wait a second. What does that mean? Bring up your calculator again. When you bring up the calculator again, when does the diver hit the water? That's right here. What is that? Well, that looks like an x-intercept, doesn't it? So, do you remember what to use to figure out the x-intercept? I do. Second calc, find the x-intercept, okay, which is a 0 value. That's right, you remembered, okay. All right, so let's mouse over to here. Okay, let's mouse, here we go, mouse, mouse, mouse. Left bound is right there. Right bound is a little bit lower. Enter, and of course guess, and look, it hit, that particular diver hits the water at 0 at 1.74 seconds into the dive, at 1.74 seconds. So how long does it take the diver to hit the water? 1.74 seconds. Beautiful. So what's the domain and range that are appropriate for the situation? Okay, here we go. Let's figure that out. Okay, so we know we start here at 3 meters. We know we go up and we go ka-splash. We hit a maximum height here of 5.36 at a time of 0.69 seconds. I think it's 0.69. Yeah, 0.69 seconds. So there's our vertex at 0.69 seconds. So, okay, that's that point. Then it comes over here and goes ka-sploosh, right, at, what was it, 1.74 seconds. Okay, so again, all you're worried about is from here to here. Now, let's do the domain. So the domain now is from 0 seconds, because you don't care about the negatives, to 1.74. So from 0 to 1.74, that's the domain. 0 is one end, 1.74. So can you start at 0? Yeah, you can, but all the values are going to be bigger than that. And remember, this is t, it's not x. We're talking about time. So time is greater than 0 or equal to 0, and equal to or less than 1.74. Because after the diver hits the water and goes ka-splash, You don't care what happens down over here. They'll swim over here. They might go swim over here and then get out of the pool over here like this. You don't really care. That's the part where you care, from 0 to 1.74 seconds. And then look at the range. Same kind of idea. You're starting at 0 and you're going to a maximum of 5.6. So from 0 to a maximum of 5.36. Okay, and you want it to be the height. But remember what we used over here. We use height equals h of t. Okay, not y. So height has to be h of t. So it's got to be greater than or equal to 0, because that's where they splash down here, right here, okay, to a height that is less than or equal to 5.36. That's your maximum. What an incredible question to do. Could you imagine doing this by hand? No, you have to use your calculator for this. Now, over here on the right has a couple other things that we got to put down. Your x minimum, your x maximum, and so on. Do you remember what the x minimum was? Yeah, it was -1, because we didn't really care what happened before the diver dove. Okay, and there's no such thing as negative time. The x max was about 3 seconds. The scale, I really don't care about that. Leave that at 1. Okay, the y minimum is also -1. The y maximum was about 5.36, so we had it up around 7. The scale, again, I don't really care about. So you have to have those values in there to get full credit on a question like this. Now, last thing that you have to figure out, it says, what is the height of the diver 0.6 seconds after leaving the board? Now, remember, time is on this axis. So you want to know, what is the height? Now, if you think about it, 0.6 seconds, if that's 0.69 seconds, the diver is actually on its way up. Okay, she's on her way up, getting close to the maximum, but not quite the maximum yet. So we want to know this coordinate right here. Well, look, that's how you figure out the value, because of course, you're figuring out an x value. Holy smokes, there's a lot of things to remember. So let's figure out the x value at 0.6. So bring up the calculator again. I'm going to get rid of all this stuff here, right? So it's not to confuse us, okay? And I want to figure out the x value at 0.6. So I can hit second calc again, the x value at 0.6. So where is she on her dive? 5.316 meters high, so she's right about there. Remember, there was the vertex right here, so she's quite close to the vertex. So 5.32 is good enough. 5.32 meters. 5.32 meters. And look at this. So a couple of key things that you got to watch for. You got to remember that this is no longer x, although on the calculator it shows as x, this is actually time. And now our domain changes. This guy may be y on the calculator, but you got to remember it's height as a function of time. And the last thing that you have to remember through all of this nonsense is to make sure that you put the proper units down. So for our domain, this should say seconds to seconds, and our range should be meters to meters. Okay, those are probably the things that I'm looking at most importantly when I'm doing a question like this.